Alright, welcome to this other videos. We are applying the properties of the determinant that I've explained in the previous video, okay? So we want to start here with this equation. This is from the tutorial. I want us to consider a matrix A, which is a 4 by 4 matrix with the determinant equal a 7, and another matrix B, which is also a 4 by 4 matrix with a determinant equal -8. I want us to find all these 7 questions if it's possible, okay? So we know the determinant of A. Can we obtain the determinant of the transpose of A? Yes, it's possible because the determinant of the matrix A is the same as the determinant of the transpose of the matrix A. So this is equal determinant of A, and this is equal 7, okay? This is for the transpose. Now, if you have the inverse of a matrix, what's the determinant of the inverse of A? We know that the determinant of A is equal 7, right? The inverse of A, if A is inversible, of course it's inversible. We don't need to show this because the determinant is non-zero, right? The determinant is equal 7. So in this case, if we multiply this, we have this is equal identity, right? If we divide this by the matrix A, so this is equivalent to A inverse equal 1 over A. When I say 1, it's just like the matrix I, right? So if you apply this, this means that the determinant of A is just the determinant of this divided by A. And this is determinant of identity. You can say determinant of I divided by the determinant of A. We know the determinant of I, identity matrix, is 1, and determinant of A is 7. So this is just 1 divided by 7. All right. Now let's look at this. This is 3. So we want to find the products of these two matrices. By definition, the determinant of a product of two matrices is the product of the determinant. So this is determinant of A times determinant of B. And we know the determinant of A is 7. The determinant of B is -8. This is -56. Okay? So let's look at this one. The determinant of A plus B, is it possible? Because here we have determinant of A times B. Can we say that determinant of A plus B is equal determinant of A plus determinant of B? Can we say that? I don't think so. It's not possible, right? So we say that the determinant is not linear. Determinant is not a linear function. Because we can't say that determinant of A plus B is equal to determinant of A plus determinant of B. In this case, we say this is impossible. Impossible. And here we have a determinant of A squared. Of course, A squared is, if you want to take it simple, you can say A squared is just A times A, right? And you apply this same property. So if B is A, then this becomes A times A. Then we have determinant of A times determinant of A. Determinant of A times determinant of A. This is 7 times 7. This is 49. In general, the determinant of A to the power n is just determinant of A, all this to the power n. Okay? Now, how about this one? The dimensions of A is 4, so this is 5 to the power 4 because of the dimension of A, right? Because if you say 5, it means that 5 multiply each row. So this is 5 to the dimension. So this is 5 to the dimension here, which is 4 times the determinant of A. So this is 5 to the power 4 times 7. This is 4375. In general, if you have a matrix M is an n by n, then the determinant of k is a given constant, okay? So with k a constant, the determinant of k times m is just k to the power n, the determinant of m. Okay, this is to generalize. And lastly, we still have the same with minus 1 here. So if you say determinant of minus a, we apply the same. K here is minus 1. This is minus 1 to the power 4, the dimension of a, times the determinant of a. This is 1 times 7 is equal to 7. So these are the properties that we have discussed in the previous video. I just wanted us to apply it here so that you can understand. Okay, so anything that shows up where you have a transpose of a matrix is just the same. Determinant of the transpose is the same as the matrix of the determinant of the matrix. Determinant of the inverse of a matrix is just 1 over the determinant of that matrix. The product rules here, when you have the determinant of the products of a matrix, is equal to the products of the determinant. Determinant of the sum of two matrices is not possible. Okay, so in this context, it's not possible unless if you know the matrix A and B, you can sum up the matrix before you can find the determinant. But in this case, it's not possible. Okay. All right, we continue here with the a square. I already defined it here. Any a to the power n, the determinant is just like a determinant of a all to the power n. N for n by n matrix m. If we generalize by saying here that the determinant of k times m is equal to k to the power n times the determinant of m. So whatever you have, you should be able to apply this property in your tutorial to solve questions, similar questions. Okay, so this all is the next question. You apply the Gauss reduction and see on a 4 by 4 matrix. So I look forward to seeing you in the next video. Thank you.